Hello everyone and welcome back to Arctic Latent. It's been a little while. I took a short vacation to get some rest after a pretty intense stretch of work, but I am back again. Today we are going to focus on all-in-one WAN 2.2 video generation workflow inside ComfyUI and how to get the best results from it. Before we dive in, I want to set some expectations. Video generation just isn't there yet, even on the closed source size. I have API access to Veo 3.1 and Sora 2 Pro, and I have spent some time experimenting with both. While they are better than open source in some areas, they still suffer from many of the same fundamental issues. And the same applies to most open source video models right now. From a wow, modern technology perspective, they are impressive. But today, nobody really has a truly reliable or broadly useful video model. That said, if you are okay with those limitations and you want to create short, interesting clips, WAN 2.2 can still be very powerful and honestly a lot of fun to work with. Before we start building the workflow, let's cover a few important things you should know about how WAN 2.2 actually behaves. Clip length is extremely important with WAN 2.2. Once you go past 5 seconds, videos can start to look stranger and less dynamic. WAN is mostly trained on 5-second clips, so that's where you will usually get the best results. This isn't always true, but it is a very reliable guideline. As you increase the length, problems with color consistency, overall quality, and prompt adherence become more common. That's why this workflow caps the length at 10 seconds. Longer videos take more time to generate and they usually look worse. That said, we will also cover Stable Video Infinity or SVI. SVI allows you to generate much longer videos with far better temporal consistency. It is not perfect, but it is a huge improvement over the old approach of stitching short clips together. Quality mainly comes down to steps and sampler choice, especially for text to video. For image to video, you can cheat a little. Starting with a very high quality input image gives the model a strong first frame. That alone can noticeably improve the final result, even with fewer steps. Poor quality LoRAs or conflicting LoRAs can significantly reduce overall quality. And finally, quality can often be improved just by choosing a more common aspect ratio, which the model generally handles better. Several things affect variation in WAN 2.2. That includes the sampler, the number of steps, CFG, the seed, the prompt, and any LoRAs you are using. Even small changes to any of these can produce very different results. Let's jump into ComfyUI and start building the all-in-one WAN 2.2 workflow together. I will break everything down and explain it in more detail as we go. Okay, we are going to cover lots of stuff. So I will try to be as much as slow, but I don't want to go crazy with like a very long video. It's going to be a long video, but I will try to follow in order because the order is very important. So sometimes I will check my notes. So first thing first, I am not going to do the same thing we did in Flux, like installing ComfyUI. You can use my ComfyUI script, which is this guy. Linux ComfyUI installer you can find in the previous video, and you will see it is super easy to run ComfyUI with even Sage Attention, which we are going to use in this case. And after you launch your ComfyUI, which is going to be ComfyUI for my case start Sage 2, because I have two installation of ComfyUI. So I am going to run this, as you can see in here, using Sage Attention. Okay, so ComfyUI is started. I can go to ComfyUI, refresh. This is going to be our workflow. As you guys can see, I am going to use get and set nodes. In my opinion, they are amazing, super powerful. I don't like creating a workflow that has like crazy connection types all around, because if you are starting this new, you are going to get lost. It is super easy. When you have something like this, get nodes, set nodes, which is in my opinion every node-based application needs to use. For example, I am a modeling and texturing artist, and I use, for example, a software called Mari, and it has this, and it is night and day using get and set nodes when you are dealing with nodes, because they make everything so much more easy to read. Anyway, I will open my manager and I will go to custom nodes in workflow. So these are the workflow that I'm going to put in the description. You need to install to follow along with me, or you can go to my Patreon. It is free. In my free tier, all my workflows are free. You can just download the finished workflow. You can open it, and after you open it, you can just click install missing custom nodes, and you will see all these nodes, and you can just install everything, and then you will have a restart button here. You can restart and you are good to go. Okay, so let me set up my screens. Let's create unsaved workflow, immediately make a save. Let's call this all-in-one 2.2, confirm. Okay, we will start with our settings, and I am going to, of course, in all my workflows, I like to make a separate group that has the most important settings. Then I will use the set and set nodes to set my nodes to be used in different section of the workflow screen. So what I'm going to do, I am going to start with load clip. Okay, by the way, you can download everything from Arctic Downloader. This is also I showed in my previous videos. This is my tool that you can download. You can choose WAN 2.2 master model. You can choose your GPU RAM, system RAM, and you are going to get the models and all the necessary files for this workflow. Like we are going to use self-forcing LoRAs like Light 2X, variation autoencoder. It will download everything. Yeah. If you are not following me on a Linux installation, you can just go to my Hugging Face, and in my Hugging Face you can go to WAN 2.2 files and versions. You can find all the files here and download. So you don't need a Linux machine to be following my tutorials, but if you are not on Linux, you are missing lots of things. So I am going to use the FP16 model, and let's go with variation autoencoder, load variation autoencoder. We are going to use WAN 2.2 from the folder, WAN 2.5. WAN 2.2 still using WAN 2.1 variation autoencoder, so don't get confused. So what I'm going to do, I am going to set nodes, connect this to this, and I will call this clip. This is our clip. Let's make same color. For variation autoencoder, I will make this red. I will duplicate this by alt left clicking, and I will call this variation autoencoder. I will make the color to red, connect, done. And I am going to use a node called seeds from RG3. This guy, very nice tool, and I am going to set node. I will call this seed connect. So what is this doing in its default form? It is always going to give me a random seed. Let's make this. Is this the same blue, or this is the same blue, or do we have the same blue? Anyway, this is fine. And what we are going to do, we are going to create a length for our clip length. So for this one, I am going to use a node called slider, which is from ComfyUI MX Toolkit. Okay. I will right click, go to properties, and go to max value is going to be 10. Okay. And the properties minimum is going to be 0. So the max is going to be 10. Value, default value is going to be 5. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is our slider. Now I am going to do something like this. I am going to use a math expression node. Okay, this is from a custom script node. This is my A. I will connect my A to this, and I will put an expression in here. Very basic math. So this is seconds, right? So if we need frames. So if I want to get frames from the second, I can do A multiply by 16. 16 is the lowest frame rate in WAN 2.2, and we are going to use some interpolation techniques to increase it, and I will talk about interpolation, and I will add 1 to this. So this is the basic math that we need. Now there is another very powerful node that I always use. It is called preview any, or Let's search for any, show any. It is from ComfyUI ease use. Why I like to use this? Because I want to double check if something that I am doing is actually working. Okay, I did some math here, but is it really working? Let's do this. So this node shows anything as an output. If I run this, I should get 81. So 5 seconds should give me 81 frames. Okay, so this is working. Okay, you can leave them as it is. I like to keep them to check, then I remove them, but just for you guys to see easily, you can keep it or remove it. Now I am going to do something here. Set node that I always use from the KJ nodes. Okay, let's see, length. This is going to be my length, and I want to be sure about something. The last time this was not getting the integer. Let's try, and it works. Okay, no problem. So this is our length. What else? What else? I am going to do some coloring to this, maybe like this. Okay, and I will do, so this is a very nice tool that's from Adore ComfyUI custom node. So what is this doing? I like to work with aspect ratios rather than giving like exact resolutions. So I will put both option for you, but I like to use aspect ratios. So if we do 1-to-1 ratio, for example, this is a ratio that I like to use in text to video, for example, and multiply by 128. Okay, so for example, again, I will show you where is show any. Okay, if you connect this to here, okay, so width is 768. So for example, if you want to go with a different aspect ratio, okay, it is going to do the operation for you automatically. So as you can see now, I am getting 5 at 20. If I go with 2-to-1 ratio, I get 1024, so on. So this is nice to have, but I will also, of course, I will put this on 1-to-1 ratio. I will talk about ratios in a minute, more in deeply, but of course, I am also going to use image size. This guy, set image size from Rest for Life. I think I pronounced it right, from this, and I will put this 768 to 1280. Okay, now what we are going to do here, if we have two nodes that's kind of doing the same thing, giving us image size. Now there is another node that I am going to use lots of times in this workflow, which is like another very powerful node I always like to use, is something called switch. Okay, so if you go to a switch, it is called unrestricted switching, this guy. Okay, so I am going to call this height. By the way, you can rename your nodes and it will make more sense. And this is going to be my width switch. Okay, so this height is going to be my input 2 if I do it like this. And if I put the height from this node to input 1, and if I do preview any, as you can see, it is showing me the first input. Why this is powerful? If you bypass this node like this, Control B, if you preview this, you will get the first one. We are going to use bypassing, and bypassing is super powerful in ComfyUI. You can make like very nice workflows by turning on things and off. It's like you can do like if else, like programming, when you really understand the magic, and it is very easy. So if I bypass this, it is not going to read this, it is going to read this, and because we have a switch and one is bypassing, it is only reading the input 2. Super easy. Okay, Control B to enable this. And if you are not bypassing, it will always get the input 0, 1. Okay, so I can remove this. This is going to be my set node, and this is going to be my height. Duplicate. This is going to be my width, and for the width, this is going to be my input 2, and this is going to be my input 1. Okay, then you can just collapse these if you like to tidy your screen. I can also collapse this. Okay, I will make like coloring stuff maybe at the end. I don't want to spend too much time on it. So now what we are going to do, what else we need? We need a model shift. Okay, so model shift is going to be a float. It is going to be from ComfyLiteral's custom node. Okay, this is a node that you can put like float values. So this is going to be my model shift. So what is then model shift? So when you generate an image or a video, the model doesn't create it all once, of course. It gradually removes noise over a number of steps. And we will talk about steps, of course. So if you use 20 steps, let's say, in your generation, that means the model goes from 100% noise, because we start with 100% noise, very noisy, to zero noise in 20 steps. Now, here is the important part. The sampler itself decides which exact noise level those 20 steps come from. So they are chosen from a much larger timeline of possible noise levels. For example, if I do, for example, without using like any shifts, we start like 100%, okay? Then maybe 88, 76, let's say 50, and blah, 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 blah. Then we go to 0%, okay? I start using this tool recently, so sorry for if I'm doing any mistakes. So switch changes where those steps are spent. So this can be super important, and actually it is, like, in my opinion, one of the most important parts of the video generation. Instead of spreading the steps evenly, Shift pushes more of them toward the high noise end earlier in the process. So for example, with the shift enabled, you set like shift number 5, then you can have something like this. It will start like this. Okay. So this means the model spends more time while the image is still very noisy. So when you generate like a video, in the beginning of the video, this is an output I am pretty sure lots of you guys are going to get, which is normal. So for example, a woman is walking toward the camera and the woman is super noisy. It has like weird artifacts in the beginning of the video, and when it comes closer to the camera, it gets like more sharper. So that's why the steps is important. That's what steps is doing. So less time is spent on final details at the very end. So why this helps? Those early high noise steps are where the model decides the composition, which is very important. It is where the model places the objects, figure out the overall motion, structure, stuff like that. That's where the high noise model is doing. By spending more steps there, Shift can improve the composition, help motion and layout, and reduce lighting between elements. So this is especially useful in video models, of course, and especially when we are using few steps sampling with speed LoRAs, which we are going to use. So WAN 2.2 has something called high noise and low noise models. It is not like we used like in Flux, there is only one model. No, in WAN 2.2, we have two models, high noise and low noise. So it is also called mixture of experts. So when you see somewhere about WAN 2.2 where it says something like MOE, it is mixture of experts. So it is like having multiple specialized internal submodels in the model, and for each token the model automatically routes the work to only one or two of them instead of like running everything everywhere. So you still load all the model into VRAM, but during the generation, only a small part is active at a time. So you get higher quality and capacity without paying the full compute cost every time. So this is why this this high noise and low noise, this is not only for WAN 2.2 of course, this is like an advanced LLM mechanism. The reason they introduce something like that is to optimization purposes. So you can like load a very high model like this, but you can separate that into two and you can still get like a nice result with a less compute time. So high noise, like I said in the shift section, so its job is to take the initial noise and follow the scheduler, step count, and the shift settings, of course. and shape the overall structure of the result. This is where like big decisions are made: composition, object placement, motion direction, scene layout, etc. Once the high noise model has done its job, it passes a partially denoised latent to low noise model. Then low noise model takes the job. So then the low noise model get that partial denoise latent and finishes the job. The low noise model is focusing on details, texture, sharpness, and cleanup and refinement. So it is like the high noise is the decision maker and the low noise is the refiner. So why this is, again, is very powerful. One model focuses on structure and the other focuses on details. So you effectively get the benefits of a much larger model without doubling VRAM usage. For people with limited GPUs especially, this is a huge advantage. You can run something that behaves like a larger model while staying within memory limits. So that's why this model shift also becomes very important. But you don't need to be like, I mean, there is a math behind it, right? You don't need to know what is actually going on by looking at like super like crazy math stuff like that. Lots of people are doing tests. The model itself is giving you some numbers for like a default value. They say this is a good number. So, but in this video, I want to show a little bit behind the scenes, so you just don't like go copy and paste, so you understand the idea what is going on. Okay, so this model shift that I like to use as a value, for example, I will call this model shift, is 8. Okay, 5 is also, I think 5 is the default recommended one. I like to use 8. Okay, you will test. AI is all about testing. You will test a model shift value of 8, 5, stuff like that, then you will see the results and you will find your best value. Remember, prompt is everything and it can change everything too. So when you use like a prompt with a model shift of 5, you can get like an amazing result. With another value, you get like a different result. This is normal in AI. So this is going to be my model shift, and I am going to call this, of course, set node model shift. When I do set nodes, I always use capital letters. Okay, this is my model shift. It automatically gave green color. Then let's give this also green color. Okay, and I can put this here maybe. Let's tidy some space. Okay, what else I need now? Another important step is steps. So I am going to do this time an integer. I'm going to do a float. I'm going to do an integer, and this is going to be my steps, set node, and this is going to be my base steps. I will tell you why I called this base in a minute. And for my base steps, I will use 30. In this workflow, we are going to use something called self-forcing LoRAs. They are very popular. And we are going to use something called Light X2. There is another one that's called Lightning. I think Light 2X is better than Lightning, according to my tests. So these LoRAs are specialized trained LoRAs. These LoRAs actively push the model toward a specific behavior. That's how they are trained. So in this case, these LoRAs are allowing, for example, very fast 4-step generation time, which is crazy. Of course, the trade-off is you are going to get a reduced prompt adherence, and it's going to be an expressive range. You are literally limiting what WAN 2.2 can do, but in exchange, you get faster generations. Now, this is very important. I don't like using these LoRAs. In my opinion, they are completely ruining what WAN 2.2 is capable of, but I am going to show them because not everyone has a 5090 or more than that. So in my workflows, I want to always show optimized workflows for general use, for people with low VRAM. Maybe you want to create some nice TikTok videos, short videos. Why not? So that's why I am going to show how to use them. Why I called this base steps? Because we are going to have a different steps for using with light LoRa's. We are going to have a CFG with and without using light 2x LoRa's. That's why I call them base steps. So I will make my base steps 30. And the second most important one is our CFG. I will call this CFG, set node, connect, and call this CFG or base CFG. Okay, and the default CFG recommended to use without self-forcing LoRa's is 3.5. Okay, like this. Okay, we set this. Now another very important one. It's an integer, not like this. Integer from ComfyLiterals. Yeah, this one. Last high noise step. Okay, I will tell you what we are doing with this. And this is generally the half of your steps. So what is this? When we are going to use high-end noise models for WAN 2.2, of course, we need two key samplers. The first key sampler, which is the high noise one, is going to use 15 steps and it will stop when it reaches 15 steps. In the second low noise key sampler, we will start from 15 steps to infinite. So this is how high and low noise works. I told you what is happening with the high and low noise model when I was describing the model shift. So this is why I will put this to 15. Okay, so we need to tell the models, hey, your job is done, and your job is done at 15 steps in this case. Now, low noise, you will start from 15. Okay, now I am going to put a switch, unrestricted switch. Okay, this is going to be my last step switch, and I will put this last high noise step to input 2. There is something going to be connected to this input 1. You can understand the logic, right? When we are creating the self-forcing LoRa light 2x section, we are going to define the steps for light 2x LoRa's in its own group, because like I said, we are going to do some bypassing logic. Hey, do you want to use self-forcing LoRa's? Okay, we will enable it, and then it is going to switch to input 1. Disable self-forcing LoRa's. We are going to have an input, a button. We will click it, and then it is going to bypass the self-forcing LoRa's group, and it will then use this number. So for now, I will keep this like this, and this is going to be last step switch. And another switch I want, unrestricted switch. This is going to be my CFG switch. Okay, we want a CFG for light 2x self-forcing LoRa's, and we want a CFG for normal workflow without them. So in this case, this 30 is the input 2. I can just go like this. Oh, this is base step, sorry. Okay, let's put like this. Another unrestricted switching. This is going to be our step switch. Same logic, okay? So 30 is my base step, and it is also my input 2. Actually, let's make it like this, because I will bring some other stuff here. Okay, switching is amazing with bypassing, you will see. And this is step switch. And what is nice, I will also set nodes for all of them. So for step switch, this is going to be my steps. For switch, I will use underscore SW. This is going to be my CFG underscore switch. And this is going to be my last high step SW. Okay, let's do a save. Now prompting time. I want to keep the prompting in the settings area because it's like a setting, right? Now let's use our first get node and let's get the clip. Okay, we don't want crazy noodles. That's why I will use get clip, and I am going to use prompt, clip text encode prompt. This is going to be my positive duplicate. This is going to be my negative. I will connect to the clip text encoder and set node. This is going to be my positive prompt, and this is going to be my negative prompt. I will make this green and negative to red. There is a default negative prompt, which is something crazy like this. You can use it, and let's save. We are done for now with the settings. I will select control, drag and create a rectangle, and click on frame nodes. Let's call this capital settings. Okay, let's see what we did. We created a slider for our length of the video, we used a basic math expression to convert our seconds to frame number, and we set it as a length. We are using two different types of nodes to set the image latent size. One is based on a ratio, one is based on direct input, and we are using a switch because you can bypass one of it and use whatever you want. In this case, I am going to bypass this one for now. We are setting the height, we are setting the width, we are using a seed node from RG3. This is always giving us a random seed number, and we are setting the seeds. We are loading our clip, text encoder. Very important, I need to choose 1 in the type. We are setting our variation autoencoder. We set our model shift with a float. We set our base steps and base CFG with an integer and float. And we set our last high noise step as an integer in here. And we created switch for base steps, base CFG, and last step switch, because we are going to have an option to turn on lightning LoRAs to use or not to use them. And we are going to have different step CFG and last step number for lightning LoRa usage, and then we are setting them with a set node. Now you may be asking yourself, how do I know when to switch to low noise? That's where something called boundary comes up. WAN 2.2 for text to video, image to video has something called boundary. So the generation, like I said, starts at noise 1.0, and then the noise decreases step by step towards 0. So while the noise is going through 0.875, okay, I will tell you what is this number. One uses the high noise model. Once it reaches, this is for text to video, once it reaches 0.875, then it switches to low noise model. So this is the math, how the model is trained for text to video. Then the low noise model is used until the last frame. Use the high noise model for the early noisy part, then at 0.775 switch to the low noise model and finish the video. That's it. Where do we know this number? If you go to GitHub of the WAN model, if you click WAN, go to configs, and if you go to, this is for image to video config, this is for text to video config. If you open text to video config, for example, if you go down, you will see in inference, there is a boundary. Okay, this is the boundary we need to know. And this is the boundary for image to video, which is 0.9. But how I am going to know where to switch my step? It's easy. We can open our ComfyUI. Let's create a new workflow. Let's create a node called WAN video sigma to step. This is where you put your, in this case, I'm going to use text to video boundary number 875, which is, as you can see, this. Where is my ComfyUI? And then I'm going to use something called WAN video scheduler. This is from WAN video wrapper custom node. If I connect my step to my end step, okay, I am going to use a simple scheduler that we are going to use in our workflow, which is Euler. Let's say you are going to use 10 steps and you want to use a shift, modal shift of 5. If I connect this to show any, okay, because I cannot run this without this, okay, so this is going to be my scheduler. Now, if I run this, this is going to give me something very nice. So as you can see, at step 4, we are reaching this amount. So I am going to start using my low noise model at step 4. If this was for image to video, if I run this, same, okay, they are very, because this is like a, because they are very close numbers, 875 to 900. So I am getting step 4. So this is what you can use. This is like the math behind it. And if you really want to put like the right number, this is not always like going to give you the perfect result. Like I said, In video generation, there are lots of things that affect your video. Prompt, steps, the seeds, the prompt is like one word in a prompt is going to give you something problematic maybe. But just want to be sure that you are in the safe zone, you can use this technique to get your number. So let's go to WAN 2.2 and let's go to CFG section. Where is CFG? Here is our CFG. This is our CFG for our base generation without lightning self-forcing LoRa. So CFG controls how strongly your model is forced to follow your input or your input image. So low CFG are more freedom, more natural motion, and high CFGs, stronger prompt control, less freedom. So if you use like a higher CFG, you are telling the model to follow the prompt more. And if you are using low number CFG, you are telling the model to, hey, you are free, whatever, you can do whatever you want. Now, there is also something very important about CFG. Higher CFGs are using more computation. And if you increase it too much, you can damage the quality. So it is like too much CFG is like forcing a big object into a tiny space, like everything is like get distorted. CFG1, which is very important because we are going to use it in self-forcing LoRa's because we want higher computation speeds, but CFG1 disables negative prompting, which is not good. This is why low CFG values are often preferred for speed LoRa's, and when we are doing CFG at 1, we are going to use something called NAG, which is called Normalized Attention Guidance, which I will show you in the Lightning LoRa section. Okay, so CFG is also very important. Okay, now we are going to create our model section. Let's start with text to video. So I am going to bring a low diffusion model, and this is going to, I am using FP8 for this video. So this is going to be my text to video, high noise. Remember, we have high and low for both image to video and text to video. So this is going to be text to video high. I will duplicate this. This is going to be my text to video low, this guy. Okay, I am going to duplicate this. This is going to be my image to video high, and this is going to be my image to video low, and I will put this like this. For image to video, of course, we need a load image node. I will put it here like this maybe, and I am going to frame this with a group, and I will call this text to video like this. I will frame this image to video like this. Now, I want to make a switch because I want to enable and disable this according to my needs. What I am going to do, I am going to create unrestricted switching that we used before. Okay, so input 2, I can put onto my load. Okay, let's do this. Let's make them. This is text to video high, and this is text to video low. This is image to video high, and this is image to video low. So I will put this text to video low to input 2 and text to video image to video low to input 1 like this. I will double click this. I will call this model switch low. This is a switcher for low. I will duplicate this. This is a switcher for high. Input 2 will be my high for text to video, and input 1 is going to be my image to video high like this. Okay, and for our image that we can use anywhere, I will set a node and I will call this image and connect to this. Now what I'm going to do, I am going to use a very nice node called fast group bypasser. Okay, fast group bypasser. This node, when you create, it is going to give you all the groups that you have in your ComfyUI. For example, it is showing me settings also here. Okay, which I don't want to show it. So what I can do, I can right click, go to properties. Let's make this color brown, and let's make this color brown. If you right click, go to properties and say match colors and say brown, it will give you everything that's inside brown groups. Now, as you can see, I can enable and disable them like this. Okay, now I enabled my text to video. As you can see, other image to video is bypassed. So right now we are using a text to video models. Now we will continue with our model section. I am going to introduce a power LoRa loader from RG3. This is for adding custom LoRas. WAN 2.2, Flux, all these models are giving you different LoRas that you can use. This is not self-forcing LoRa. Self-forcing LoRa is different. Self-forcing LoRa, like I said, it is for less time generation. Its purpose is that this is like a LoRa, for example, to create a cyberpunk character. So I want this to be inside my chain. So of course the model will go to output of the low switch. So this is low. I will duplicate this, and this is my high. As you can see, these guys need our clip text encoder. This is where get and set nodes are, like I said, becoming very handy. So I will just get my node called clip and connect to both of them, and I could put them in between. Now, this is where we are introducing our model shifting. It's a node called model sampling. We are shifting the model. And we already set the model shift. So in here, the model goes to the high. Let's also call this power LoRa loader high, power LoRa loader low. I want both of them for high and low, and get node model shift to my shift value, just like this. Now we are going to create our self-forcing LoRa section. For self-forcing LoRas, we are again going to bring loader. This time, be careful. I am using a node called LoRa loader model only. Now you may say why you are not using power LoRa loader, because power LoRa loader needs a clip, where LoRa loader model only needs the LoRa itself. When I use this with a clip, I find the results not good. That's why I am only bringing the LoRa. I am not using this power LoRa loader. Okay, so now I am going to connect this to model. This is going to be my self-forcing LoRa from light X2 to video for text to video. Okay, so this is going to be my text to video high noise. I will duplicate this, and this is going to be text to video low noise. So the LoRa strength for both of them, 1:1, is recommended. Some people like to use and say they are getting better result with high step LoRa in strength 2. You can test. I will keep them at 1, okay? And this will get my low model. And this is going to be named light. Let's name them light X2 high, copy, light X2 low. As you can see, even in the name it says 4-step. So they are trained for generating a video in 4-step. Now, let's make some room here like this. I am going to create a float for my light CFG, which is going to be 1, okay? Now we are disabling negative prompting, which we don't want, but we are going to introduce something for that. And I will make this, let's say, red. This should be a float number. Don't make that mistake. Also here, where is it? 8.0. This is why we are using a float, okay? The difference between float and integer, okay? So this is a float, and this is going to be my set node light CFG. I don't know why it gives green. And I am going to create an integer from ComfyLiterals custom package. And for this is going to be our steps, light steps, set node light steps, duplicate this, call this light last high noise step, and I will make this 2. Half of this should be fine. If you go to this thing that I showed you, if this is text to video, and if I am using a shift of, let's see, 8 with 4 steps, as you can see, our step is 2. Let's do a save. Let's go here, set node, and let's call this set, oops, not this one, light last step, okay? Here is the thing. There is a node called NAG from KJ nodes, one video NAG. Let's call this high. Default values are fine. And let's call this low. We will connect our model into this. They need a conditioning and they need a negative prompt. So get node, because NAG is for negative prompting. Don't forget, negative prompt. We can connect to this. Now, normalize attention guidance. It is like an alternative technique that allows for the use of negative prompts at the CFG level of 1, often resulting in faster generation speeds with certain models like WAN 2.2. Fast step, so few step diffusion models like these guys, self-forcing LoRAs. They facilitate a rapid inference, but generally lack support for CFG, making negative guidance ineffective. So it works inside the model's attention layers to enforce the negative prompts more reliably than the traditional CFG, especially when you are using few sampling steps like we do here. So it keeps the negative guidance stable, and it doesn't need like retraining, and it works across image and videos. So this is a spatial node that allow us to use negative prompting while using CFG of 1. Okay, now this is very important. I am going to select these guys and frame them and call this self-forcing LoRAs. Self-forcing finally. Okay, like this. And then what I'm going to do, I am going to set node like this outside of this group. You will see why. And I will call this light because of the self-forcing LoRa's name, light 2x. Light high, duplicate, and this is going to be light low, like this. And let's make this a different color, maybe like this. And let's go to our settings section, because now we introduce some additional steps, right? And we have switchers that are waiting for these guys. So remember, we have step switch, which is this guy. So in the step switch, what I am going to do, I am going to bring a get node, and this is going to be my light steps. Okay, and it will go to input 1. So our step switcher for a normal workflow versus the lightning LoRa is done. Another get node, I will choose light CFG and connect to input 1. Another get node, light, what was the name? Light last step to input 1. So our last high step switcher is done. Okay, what I am going to do in here, pass group bypasser, and in here what I'm going to do, I can copy this group name because it works with group names. Double click, Control C, come here, right click, properties, match title, paste, and it will only give me this. Okay, so if we want to bypass this section, we can use this. Okay, our self-forcing LoRa section is done. Now let's create a latent. We need our width of the image, not set node, get node width. Let's duplicate this and select height. We need our height. And what else we need? We need the brain for this operation, which is 1 image to video. Width is going to width, height is going to height. Oops, like this. We need our length. We need our positive prompt and negative prompt, of course. Positive, negative. Let's make this green. And of course, we need our variational autoencoder, and we need our image. If we are using an image to video generation, get node, image to image, start image. Oops, like this. Now we need the output a positive, negative, and latent from this. What I'm going to do, I am going to set node 3 of them. This is going to be just to not get confused with my positive prompt and negative prompt. This is going to be my 1 positive. So I can understand this is the output of the 1 image to video. This is 1 negative, and this is my latent. Let's connect them. Of course, we need a variational decoder to decode our image, latent image. And this is also going to need my variation autoencoder. And this image is going to be my final image. And I can say set node final image. Now I need to connect my latent image to here. But in this workflow, I am going to use the default 2-sampler method, the TripleKsampler method, and also another custom sampler that I'm going to show you. So we are going to use 3 different sampler operations in this workflow. So I want to give you guys options to test and find your best results. So this guy I will connect later when I am creating the sampler section. So I can group this and call Latent and maybe give it a color like purple. Okay, let's save. Now we need to start generating the image. The most important part, key sampler. The sampler as the method the model uses to turn noise into a video or image, and it decides how the model solves the problem, how noise is removed, how variation appears, how stable or chaotic the result looks. And the scheduler inside the key sampler, it's like the rule book the sampler follows. So it decides when and how fast the noise is removed during the generation. Important thing to remember always, samplers and schedulers always work together. You never really change one without affecting the other. Different samplers, scheduler combinations can produce very different results, which we are going to see, even with the same prompt and seed. So for example, we are going to implement a sampler called ClownShark. It can produce very different results compared to standard key sampler, even with the identical settings. So keep that in mind. So in here, we will start with standard sampler. For standard sampler workflow, we need a key sampler for sure, the advanced one, and this is going to be my high, duplicate. This is going to be my low. These guys work like this in chain because we start with high noise, then we continue with the low noise. So the latent from high goes to the input of low. Because I will put some nodes here, I don't like to use them side by side. I like to use them like this. So my input nodes are going to be here, and this is going to give me my final set node. I will call this standard. Oops, it's going to be my standard latent like this. Okay, so now for example, I can go to my latent section, put some space here. Maybe I can put it like this. Get node, standard latent. I am going to have a unrestricted switch here, and the input one is going to be my standard latent, and then this can go to my variational decode. So we will have TripleKsampler here and the ClownSharksampler sampler here. Okay, for now this is good. Okay, the most important section. We will start by bringing our high model. Remember, we called it light, where is it? Light high. Okay, and we will bring our get nodes. Okay, let's duplicate some because we will use some. So this is going to be my one positive, and I will collapse them after connecting to give more space. This is going to be my one negative. Oops, this is going to be my latent. Collapse. Here is the important part. For our high noise, we are going to bring a random seed, which we already set up. This seed is going to be connected to noise seeds. So there is a reason why we are only adding a random seed to the high sampler. The high noise stage is where the seed actually matters. It controls, like I said in the beginning of the video, how the composition and motion evolve. So changing the seed here gives you the results, different results, right? The low noise model is just refining what is already exists in the latent image that it gets from high noise. So changing its seed usually don't produce meaningful differences. Okay, this control after generate, we are going to use fixed. We don't want to generate a number randomly after a generation because we are already getting a random number from that node that we set for seed. And what we need is get node. Let's see how much we are going to use here. But you see how it is so much more easy to go like connecting this guy over here somewhere, like all these like spaghetti noodles everywhere flying. In my opinion, this is also so much more better for anyone who is starting to learn ComfyUI. You can understand, oh, this is the section that's for this. Okay, we set stuff here and then we use this stuff that we set here in this section rather than trying to understand which node is connecting to which. So this is going to be my steps. Remember, we have a step switcher and it's going to be my step switcher, this guy, collapse. We have a CFG switcher, which will connect to our CFG. We are going to use Euler sampler with simple. Let's also collapse this. This is my low model. So this is going to be my light low collapse. And I can get my negative from this, positive from this, and latent is already coming from this. Don't forget, because they are chained. And of course, the most important part right now, we will start with a step of 0 because this is the first generation, first node, high noise. It always starts with 0, but we need to bring our get node last high step switcher. Where is it? Last high step switcher, this guy, to end at step. So whatever this number is, the noising of the high is going to end at that number. Very important to enable this. Return with leftover noise, because we are going to have a leftover noise from high noise. This is the idea of high to low workflow, right? So we need to enable this, so it can give us the remaining noise, so the low noise model can refine. Another very important part, we are not adding noise in the low noise. We are refining the noise that we already have. That's why we are now disabling this. And noise seed, 0. Control after generate, fixed. We will get the steps from our get step switcher. We will get our CFG from our get CFG switcher. Sampler, same, Euler's simple. Start at step. Now, just the opposite. We connected get last high step to end the high noise, but we are going to start with it in the low noise model. So this will connect to this. And you can keep this as infinite, 10,000, which is the default, is fine. And if I don't forget anything, let me double check. We should be good to go. Okay, good. Now I will show you something nice. In a workflow like this, remember, our non-self-forcing LoRa workflow is using steps of 30. Our self-forcing LoRa is using a step of 4. And now this is enabled. If you go here, when you are using these switches, that's why I introduce you this node, show any. I like the double check, because I don't want to have something that maybe I didn't see, but it is giving a wrong number, and I am trying to find what is wrong. So this is where this show any node comes very handy. So if I connect this show any, for example, to my get step switcher, I should get 4. If I go to here and disable enable self-forcing LoRa's, look here what happened. We bypassed. Now I should get 30. That's the logic. So why bypassing is super nice? When you bypass this node, this group, this guy is now connected to this, and this guy is now connected to this. There is a difference between bypassing and muting. If you mute these nodes, okay, then when you run your workflow, you are going to get an error. Says there is a problem, some nodes are blah 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 blah, because it is going to run the workflow, but some of the nodes are disabled. In this one, the nodes are disabled, but it is bypassing to the previous nodes. That's why bypassing is, in my opinion, one of the most beautiful things in ComfyUI. Anyway, let's enable self-forcing LoRa's, and let's call this standard sampler. Also, let's fix our terrible grammar like this. Let's do a save. Now, let's go to our real generation. Like, I still don't have the video output. Now we are going to create the video output section, which we are also going to introduce some post-processing effects. For this section, I am going to do something like this, and I will call this models. Okay, yeah, models is fine. Now, to finally get the output that we are looking for, we will start with bringing our final image. And I like to use a node called get image size and count in this section, again, for checking that I use the right settings for width and height, and my my length is correct. So when I generate something, I will get my image, but then I will also get some numbers here. It is going to give me a number here. I will see in the node itself. That's why I like to use this node. And I will see the count. The count is the step for the frame, how many frames that I will see. It is like good to have to check if something happened that is not what was your settings you set in the settings section. So we are going to use video combine from ComfyUI Video Helper Suite. This is going to be my images like this. This is going to be 16, not 17. File name prefix WAN 2.2, let's say. The format is going to be, where is it? If you want like very small images, sorry, video file sizes, you can use video 265, but I will use the more general one for this workflow, 264 MP4. This is fine. This CRF is important. CRF is the quality that it is going to use. It is like the encoder to encode this video. So CRF 19 is a good number to get like a nice result. But I am going to use two video combine nodes. One is for before post-processing and one after post-processing. So this is my first node that I use to preview my video before post-processing. So that's why I can use this like 10. Okay, it doesn't need, because this is going to save the file. I don't need to do something like a big file. I mean, it is going to be, these are small clips and it is a good encoder. It is going to be a small file, but this is going to make it more smaller. I don't need to save any metadata. And I don't want to save this, and I will enable ping pong. Ping pong is loop. I want to see a loop of my video here. Now, here is the important part, interpolation. So WAN models generate a video of a low native frame rate, usually around 16 frames per second. So frame interpolation adds new in-between frames to smooth out the motion and increase the frame rate, of course, commonly to 30 or 60 frames per second. So when it is done correctly, it makes the motion feel more natural, of course, less jerky. However, it can also give you some weird results. So there are different interpolation models that we can use and choose between them. There are some which I am going to introduce now, which are doing a very nice job. I like to use. So it is going to be, again, optional by choosing whatever you want. Some of them are more expensive in computation, of course, and some of them are much faster. So you can try them and you can compare your results. So if I have a guy here, frame 1, and if I have the guy here in frame 2, this interpolation automatically adds an in-between frame. Let's say this is a guy walking. It is going to add an in-between frame between 1 and 2 to make the motion much smoother. So how we do interpolation? We will start with 32-bit, 32 FPS, sorry. Lots of definitions. I am getting confused. Let's create an integer from ComfyLiterals, and this is going to be value of 2. This is not the right node. Integer literals, yes, this one. So this is going to be 2, and I will duplicate this, and this is going to be 32. I am going to use a switcher, unrestricted. This is going to be my frame multiplier. Okay, let's say frame multi switch. This is going to be my input 1. I will need another one here, and this is going to be my frame rate switch. Let's duplicate these guys. For 60 FPS, I need to multiply with 4, and this is going to be my FPS, and this will go to input 2 of the frame multiplier switch. This will go to input 1, and this will go to input 2. Okay, set node. So this is interpolation, and this is frame rate. If I select them, group them, 32 FPS, 60 FPS. Let's call this interpolation. Now let's do some post-processing. I can do like a color correct node. This is a nice node that's coming from ComfyUI Art Venture custom node. This will get my image from this. So as you guys can see, you can define temperature, hue, brightness, contrast, stuff like that in here. So there are 3 interpolation models that we are going to use in this workflow. In my opinion, they are more than enough. So we are also going to have switchers for them, of course. So what I'm going to do, I will bring the first one. It is called GIM VFI interpolate. Okay, this is our first interpolation method. This guy needs a model. If you drag from this, it is this load, download and load. Yeah, this guy. It is automatically downloading the model for you if you don't have it, like this. And this image, of course, is going to come from this color correct node. The other one is called Rife. All these nodes are coming from, by the way, different custom nodes. For example, this is coming from a very nice custom node called, these are coming from a very nice custom notepad called ComfyUI frame interpolation. So I will choose this one. Again, the frames in this case is my images. And the last one, which is the most expensive one, but my favorite one, is the film VFI. And the frames are the images. Now, what we need here, we need two get nodes. We need a get node, and we will grab our interpolation value. As you can see, this has interpolation factor, this has multiplier, and this has multiplier. So this will go to interpolation factor for this one, because this is a different custom node, as you guys can see. So rather than saying multiply, they are using the term interpolation factor. So it is multiplying. So it is the same thing. Multiplier, multiplier, multiplier. So this will go to multiplier like this. And now, if you do like this, you cannot group this because this is a single node. I want to group this. You can left click and right click here, add group for selected nodes. And this is going to be my Gym VFI. Same thing for this. Rife VFI. And same for this. Film VFI. And let's give them color of pale blue. Not pale blue. Blue. Like this. And I will bring fixed groups muter because I want to disable whatever I don't use. It is going to bring, like I said, all the nodes, all the group nodes that we have inside the workflow. What I can do, I can right click, go to properties, match colors and say blue. Yep, okay. Now I need a switcher, unrestricted switcher. This is going to be my VFI switch. Input 1 will be this. Input 2 is going to be this. Input 3 is going to be this. And I want image sharpen. Why I like to use this? You don't need image sharpen when you are creating an image to video generation, but when you are doing text to generation, maybe you can get a result that's not like the desired sharpness level. So in this case, you can add some sharpness in the post-processing. So this will go to my image and I can set some settings here. Sharp. Okay, sharpen radius is one is good. Then what I like to add to the videos is some film grain, because this is post-processing, right? So there is a nice node from Rest for Life. It's called film grain. Again, also, these are some expensive nodes. Keep that in mind. So I will connect this to this. I will decrease the density of the grain, decrease the amount, because I tried the values. I know it is very dense and strong effect when it is intensity of 1. So you are going to try different numbers here, but this is good. Let's call this post processing and bring this guy to here. Okay, text to video is enabled, self-roasting LoRAs enabled, and I will enable film VFI. I did a save, and after our post-processing, now it is finally time to render our final video output. Again, video combine, the image will be this, very important. Get node, frame rate, because we want the final frame rate here that we set to frame rate. Again, I can call this WAN 2.2 video H264 MP4 and CRF 19 for good quality output. I don't need save metadata, but you can. And I don't want ping pong here. This is not a loop, and I want to save this. That's it. So let's do a save. Okay, now we have a video with our standard K-sampler, and it is looking great in my opinion. And this is the before post-processing and interpolation. As you can see, the video is looping and it is not like as smooth as it is, and it is very normal. It is 16 frames per second, and the prompt I used is a woman walks forward toward the camera through a long, narrow, dark hallway. The camera is positioned directly in front of her. It is very important to create a prompt that defines your camera movements, like the camera is positioned directly in front of her, performing a continuous backward tracking shot, smoothly moving back forward. So for prompt, ChatGPT is your friend. You can say, hey, I want to create a WAN 2.2 positive prompt, and this is what I want to create. And I want very basic. I want a camera that follows the woman, blah, blah, and it is going to give you a very nice prompt. As you can see, the hallway. So then I am defining what is the environment is look like. She moves slowly and cautiously, stepping quietly as if afraid to make noise. Her shoulders are tense, blah, blah. The hallway is dimly lit with the weak flickering overhead lights. Lots of definition, and let's see our interpolation. As you can see, it is so much more smoother, and we have some nice grain I added. It is a little bit strong. I can probably decrease it, but yeah, I wanted to create something like a woman is like walking toward like a scene, frightened, like scared, and it is like a dramatic scene with some corridor lights, stuff like that, and it did a nice job. This is only with 4 steps, by the way. Remember, only 4 steps to create this video. So lighting LoRAs working very nice when you use them as much as with the right settings. But believe me, when you are using lighting LoRAs, at least disable them, okay? Because we have a very basic switcher that we defined here, disable self-forcing LoRAs. At least try once with your prompt what are you getting with like 30 steps without self-forcing LoRAs. Believe me, it's going to be much more better. Because self-forcing LoRAs, we are limiting the capabilities of WAN 2.2, but like I said, this is still very good. Now, let's jump to something called TripleKsampler method. So what is triple sampling? So like I said in the beginning of the video, WAN 2.2 has split expert models, high noise and low noise, and this special node called TripleKsampler lets you explicitly handle an initial base pass without using self LoRAs and high noise that we know, then low noise. So people are doing lots of tests when a model is released, and they are trying to find a better way to create what the model is capable of. So lots of people did these tests, and they find out that when you are using like 3 samples, one for your base without step LoRa, and one for your high and one for your low, it can help with the motion, detail retention, and avoid issues like slow motion. Because in WAN 2.2 there is a slow motion issue where you can get sometimes. It is like a problem with the model if you don't use like the correct sampling, correct steps, etc. So this is just a node that wraps these 2 key sampler nodes together and with some extra helper combinations inside. So you can literally do this on your own with 3 different key samplers, but this custom node is wrapping this workflow into one and makes our life easier. So the first key sampler is like the base denoise. So it is like a strong initial noise removal to build the coarse structure of the image, and the lighting high, which we are going to use. Sorry, not lighting high. I am talking about the model that we created. The high noise model, of course, it is adding high frequency details, and it is guiding the motion. And the low noise, this is like just the same with the high and low. You guys already know what they are doing. So with the low, it is polishing the fine detail, but we only have like this extra first pass to denoise our base and create a much cleaner, much sharper, much better result. So one of the most important part, of course, of this 3K sampler, because it is not about wrapping those 3 nodes. In the beginning of the video, I was talking about this boundary that text to video, image to video is using, and I showed you guys how to, in here, how you can find your last high steps according to your scheduler and model shifting. This custom node is doing that math automatically for you. So that's also very nice. So let's jump to that. Let's do a save. And in here, I think we can create our TripleKsampler. So for TripleKsampler, we are going to need, first of all, an extra node for this workflow to make things easier. Double click, switch, strategy, advanced. Okay, I am specifically putting this now in the text to video, and in switch strategy, we are going to say, hey, this is a text to video boundary. Now, what is this? It is this text to video boundary set to 0.875. Okay, we defined that with that node. And then I will duplicate this to image to video section. Let's make some room here. Okay. And now I will switch this to image to video boundary. Now I want a unrestricted switch, and this is going to be my strategy switch. Input 1 is going to be this, and input 2 is going to be for image to video. And then we are going to set a node and call this strategy. Okay, because we are going to use this. The reason I am doing this because of the nice option that we added to our workflow to switching image to video and text to video. Now we can start our TripleKsampler workflow. Okay, of course, the node that we need is TripleKsampler simple. There is an advanced one, but I think his simple one is already enough. Now I can get everything from here. That's also another very nice feature of get and set nodes. I can just connect them like this, but still it's going to create some spaghetti. I don't like them. I hate them. So that's why I will duplicate them. So as you can see, this node needs our lightning high, lightning low. In this case, lightning means your self-forcing LoRa. I told you in the beginning of the video, there is two very popular self-forcing LoRas for WAN 2.2. One is Light 2X, which we are using. The other one is called Lightning. So I think the person who created this node was using the Lightning one. It doesn't matter. We can connect the Light 2X to these. So I will get my lightning low also, which is from here. Oh, by the way, again, terrible English. I'm sorry for that. Where is it? Where is it? And it will update everywhere, which is nice. Okay, the grammar is fixed. I need my low. You remember what we did here when we are creating our model structure? I created a base, or I didn't. Yeah, we don't have the base high right now that it needs. So how we can get the base model without the self-forcing LoRa? It's very easy. I can do a set node to this. This is high, and I will call this base high. Why I am not just using this if the idea of bypassing is working like eliminating this, because there is a shift here for the base high. We don't want to use this shift. Okay, this is how the TripleKsampler works as far as I know. That's why I put it here. Get node base high. So let's connect these guys. Collapse. Lightning high is this, lightning low is this. Let's bring our negative and positive and connect. Let's bring our latent, connect. Let's bring our seed and connect. We will keep the control after generate as it is because this is how the node works. It is default to randomize. We keep it in randomize. Sigma shift is model shift. So we are going to get our shift to connect to that one because we define the shift. Then it makes the step mat itself. So get node model shift to sigma shift. We need our base CFG for this, and base CFG should be already 3.5 for a WAN 2.2 workflow, but just maybe you are changing it in the global settings. I will bring it here. That's why we defined it. Base CFG. Lightning start. It is the self LoRa base that is always going to start with 1. And the lightning steps is going to be the steps because we are setting the step ourselves still. Get node, light steps. Where is it? Here. To lightning steps. Euler simple. Here is exactly where you change, but we did some logic because we are using turn on and off switch for image to video and text to video. So we don't want to do this manually. We will bring our get node strategy. Okay. Sampler, Euler, simple. Again, if you put a show any and connect this to this and run this, I should get text to video boundary. If I enable image to video, I will get image to video boundary. Okay, I can delete this. And that's it. Let's create a group called TripleKsampler. Put it here like this. Maybe we can put them like this. And of course, we need a latent set node. This is going to be my triple latent. And don't forget, we have a switcher here. I can get node triple latent to input 2. Now, what I can do, what color is this? Purple. Muter, fast groups muter. Match to colors. Oh, this is latent purple. That's why. Let's make this color pale blue. And let's create that again. Fast groups muter. Right click properties. Match colors. Purple. Okay. When you are dealing with lots of stuff, of course, you are getting confused. These guys are going to be purple and purple. And now face muter, face groups muter, properties, match color, purple. Disable standards and bring this guy over here. to our global settings. And maybe we can do like this. It makes more sense. Also, let's make a switch for this. What we can do, we can make a color for this. Let's do a save. So let's make this color yellow. Best groups muter, match the color, yellow. Where is the other yellow one? Yes, this one. Something weird happens. I cannot select my groups. I don't know why. I will refresh. I still cannot. Something weird is happening right now. Just a second. Okay, finally. Can I select? I can select this, but I cannot select this. It's very interesting. Okay, it's kind of a bug. I am not going to spend time on that. So maybe I can do a different color. Cyan, I think I never used. Properties, match colors. Yes, and I can take this to here. And maybe these are going to be better next to the settings section that's here. So we have text to video enabled, self-forcing LoRAs enabled, TripleKsampler enabled, Thin VFI is enabled, and 32-bit is enabled. Let's see if 60 frame per second is disabled. And yes, it is disabled. Post-processing here. Let's give this a color of brown. Did I use brown anywhere? No. Fast group bypasser. Properties, match colors, brown. These guys are brown. And now I cannot change them because of this stupid bug. Change the color to green. And we can bypass the entire post-processing if we want or not. Okay, let's do some optimization with size of these guys to make some room, to make them look better. Okay, let's go to our TripleKsampler. Now, what we are going to do, the settings is done. We just need to integrate it to here, of course. So the good thing about these switches is we don't need to do anything because we already set that up. So because we have a switcher here, as you guys can see, when you disable the standard latent, this guy is not going to give any input to input 1, and that's why the variational autoencoder decode is going to get the triple latent. I am going to run this and I will show you the results. I will stop the recording here, then I will continue from, because I am recording at the same time. My GPU is literally dying and the video is getting chopped off. So let's go to look at the preview. Okay, again, we are done. We have a very nice results again with TripleKsampler, and you can try 2 samplers. If you don't like it, maybe you want to improve it, and you can try TripleKsampler. This is why I am building this tutorial. I am trying to give you all the options in one package. And yeah, I am generally very happy with the result. And let's jump to our third sampler, which is a custom sampler called ClownSharksampler. So ClownSharksampler, it's a different sampler that's been created by Rest for Life, I will say family. And yeah, it has a sampling called BongMat in it. You can read all the details inside this GitHub page. So BongMat is a sampling method that keeps the denoising process consistent by continuously aligning earlier latent states with later noise predictions. So instead of denoising in a single forward direction, it applies small backward corrections each step. So these early decisions, what they say about structure and motion, stay compatible with later refinement. So according to their claim, this makes the generation more stable, more coherent, and higher quality, especially with low step counts and video models like WAN 2.2. So I read some good feedback about this sampler. So I just wanted to give you the options to also play with it. So let's jump to our workflow. So we are going to our samplers area. Okay, what we want to do is ClownSharksampler, this guy. This is our sampler. Of course, we want to, and I will make them like this. So the output, again, just like 2 samplers, is going to be my latent image for my second sampler, like this. And this guy needs our lightning high, which is this guy. Our positive and negative, we want our latent to latent image. Model positive, negative, latent image. We are not doing anything for the sigmas and guides and options. We set this to 0. This is also 0. For this sampler, they suggest to use multi-step res underscore 2m sampler name. We will use simple scheduler. Okay, we need steps, so we are going to get our steps. Where is my get step switcher? Gets CFG switcher. Okay, let's put them here, enable them because they were in a disabled bypassed group. So I just click Ctrl B to re-enable them. So this step switcher is going to steps, of course. CFG will go to CFG switcher. So this steps to run is our last high step. So I can get it from here. There's a typo here, but okay, no problem. So this will go to steps to run. I can put this here. We need a seed, of course. Let's duplicate this to seed. We want to set this control after generate to fixed, sampler mode to standard. And of course, the most important part is the bong mat is set to true. Deno is at 1. We are not changing it. We need the light low for our second one, and then positive to positive, negative to negative. Latent is already coming from here. Steps to step switcher and CFG to CFG switcher. And this steps to run, we are not connecting our last high step. We are keeping it at -1. And of course, the seeds, they also recommend -1, a random value. And we want fixed sampler mode. In this second one, they suggest to use resample and set to true. And this output is going to define our ClownShark latent. And let's go to our latent section. Let's bring it here, get node. ClownShark latent to input 3. Let's make a group. ClownShark, I think K is capital, sampler, like this. And if I give this the same color like the other samplers, I should be good to go. Let's put this here. Don't forget, when you duplicate stuff from a bypass group to re-enable them, Control B, Control B. So Control B after bypass is mute, then another Control B is enable. Let me see. Yeah, everything is enabled, right? Okay. Model to model, positive, negative, latent. Cool. Multi-step, res2m, simple. 1, fix, standard, true. Bong mat is set. Bong mat is set. My low model, positive, negative, latent image coming from the first node. These are 0, res2m, simple. Steps to run, -1. The noise is 1, seed is -1, it's a fixed value, and this time the second node is using sampler mode as resample. So if I go here now, I should have it like this. And let's go here again. Did I connect CFG? CFG is connected. Yeah, it is ready. So when you set your things with switchers, that's it. You just need to add some modules to it, and it will just work in the entire workflow. That's the beauty of using bypass. So let's do a Control S, and I am going to run this, and I will show you guys the results. Okay, the result is here, and it's good. I like it. I just don't understand why she's making this, but it is all about prompting and changing the prompt. Of course, I told you in the beginning, different samplers are going to give you completely different results, but I am looking at the general picture, the quality, the details. Plus, I am also giving some sharpen to this. So for example, for my taste, this is a little bit too much sharp, but it is coming from this. I can just disable this. But yeah, I am really happy with these 3 results from the standard one and the TripleKsampler, the ClownSharksampler. They are all giving me very nice results, and I hope they will also give you nice results. And remember, we are using Lightning LoRAs with only 4 steps. So in my opinion, this is pretty good. Now, we cannot finish this workflow without how to generate a long video, right? So we are lucky, because if I made this video a month ago, that wasn't available. I am sorry for that. So we have something called SVI. So we have Stable Video Infinity. It's a new way of creating longer videos with WAN 2.2. Before, people used to do getting the last frame of a generation and start a new generation from the last frame. In my opinion, it was very bad, because you don't have the previous motion that you have, and then you get this like weird results, like inconsistent motion in between that frame. It was obvious with all of the examples I tried, and it is normal to have that problem, of course. But this one, SVI. Did I save it here? Let's see. Yeah, here, stable video infinity. So stable video infinity is able to generate any length videos with high temporal consistency, plausible scene transitions, and controllable streaming storylines in any domains. This repository contains the model, weights, blah, blah. So this is doing something very nice for this in between frames, that you don't see that weird results that you literally get every time with stitching method. So we are going to look at this, and I tried this before and I am really liking this, and we are going to implement this into our workflow and we are going to call it out. And I think this is going to be a really nice all-in-one workflow. I hope you guys also will like it. So let's jump into stable video infinity. Okay, let's continue with our long video generation. We are going to use stable video infinity, but before that, I just realized in the last video we didn't create like an image to video. We did like a text to video with 3 different samplers, but just want to show you guys because we already set that up. I put like an image and everything is working just perfectly. So we just created a image to video from our workflow. So just keep that in mind. And now we are going to have some fun. We are going to use SVI. So we are going to use different LoRAs for SVI, because SVI is also a LoRa. Everything is under my Arctic Latent 1.2 files and versions LoRa section. You can find the high and low ones, but if you are using Arctic downloader, of course, these are already downloaded for you automatically, and they've been uploaded to their own folders inside the ComfyUI LoRa's folder section. We are going to use subgraphs. Subgraphs is a new feature in ComfyUI, and I didn't want to use it in this entire workflow because I like my first videos to be like as much as like educational, I think I can say. If I can start doing like subgraphs, in my opinion, people who are new to WAN 2.2 or ComfyUI, you are going to get lost because it is a way of optimizing your graph for sure, but it is also going to make you think like what's happening here. So that's why this workflow right now, as of now, everything is open. We use set and get nodes, which we will continue to use. But for the long video generation, now it is a good time to start using subgraph, because what I want to do for long video generation, we are going to create 5-second clip multiple times. So for example, I am going to have a module for my first initial 5 seconds, another one for the other 5 seconds, 5 seconds, 5 seconds. These all modules needs their own text prompts, their own WAN to SVI node. To put them without subgraph, like in here, we are going to have like a crazy lots of nodes. So this is where subgraphs can be super handy, because we are going to create a subgraph, then we will duplicate that subgraph for our additional clips. You will see and understand better when I am doing it. We can just start with like a text prompt. Okay, I just need a node to create and enter into my subgraph. So if I create like a clip text encode prompt, this guy, if you click it, and if you click this guy, it will convert the selection to subgraph. As you can see, this is now a subgraph. Every subgraph is going to have this like blue icon next to them, and I will call this initial. And if now, what is subgraph? Subgraph is like another node graph that is inside this. So it is like a nested subgraph. So if you want to enter inside this, you can click this. As you can see, when you enter this, you will see initial and your main root workflow. You can switch between them like this. You can also double click to this to enter. Now, what is new to you, if you never use this, you are going to see this thing on the right and on the left, and you can click on it to move wherever you want. Okay, so this is input and this is output that we are exposing to the outside, to the root level. Now you are going to understand much better when we are doing it. So in our initial clip generation, we are going to, let's see what we need. We need a clip prompt like this, of course, and this is going to be, actually let's do it like this. Let's create a key sampler advanced node and let's turn this into a subgraph. Okay, and let's call this initial. Okay, let's go inside, and now we have a key sampler. For this workflow, I am going to use 3 samplers, but I am not going to use TripleKsampler because TripleKsampler has a higher step for base noising. In this one, I want to use lesser steps for my first step. Why I am doing this? Because we are still going to use Light 2x LoRAs, but like I said in the beginning of the video, Light 2x videos are limiting WAN 2.2, and for a long video generation like this, in my opinion, from my test, they are not doing very great. What I am going to do, I am going to create a sampler for the with higher steps, and that's going to be our overall structure key sampler to generate like a nice structure of our first image, which is going to have like a good details, sharp details, stuff like that. Then we are going to use a light 2x high sampler. Then that is going to connect to a low light 2x sampler. So the second one is going to define more details, and like we discussed in previous video, the low one is going to be a refiner for small details. In my opinion, 3 sample is working better in this case. But you can always bypass the first sampler. I mean, you guys, I think, already understand how bypassing is working. So let's start building our stuff. We are going to use this in a second. So we are going to need a clipped text prompt. Okay, this is going to be my positive. I will duplicate this. This is going to be my negative. Let's make some room. Now this node is new. One image to SVI. One image to video SVI Pro. Okay, I was wrong. This is not a native. It was from KJ nodes, which we already installed. I think it is like one of the best nodes. And so, of course, positive to positive and negative to negative, and positive to positive, negative to negative, latent to latent. Okay, I can just paste some negative prompt here like this: overexposure, static blur details, blah blah. And now this is very important. This workflow is working with the brain of this node is this anchor samples. Okay, so we are like chaining multiple latent images together, and the way this model is trained, this LoRa, it is making that nice smooth linear blends in between frames, so we don't get like weird results where we used to have with like manual stitching. So what I am going to do, I am going to create another one sampler, another one. This is going to be my base, this is going to be my high light 2x, and this is going to be my low light 2x. Latent to latent, latent to latent. We change them. Positive, oops, positive to positive, negative to negative. Okay, positive to positive, negative to negative. Okay, what else we need? Of course, we need a variational decoder. We are creating an image. This variational decoder will get the samples from this latent image. And now I want an output from this. If you connect this to this, it is going to give you whatever the name of this. What is nice about subgraphs, you can rename those. Okay, but for now, let's remove this because there is something that I don't like about subgraph. I think they will introduce it. And now you are going to see, you cannot change the order of this, which is not a big deal, but I want to have an order. So let's start by setting our samplers, like the most important part. So for the base, which is going to be 7 steps, okay, we want randomize. Okay, of course we want to add noise, and in the second one we don't want, because these are going to be refiners. We are removing to add a noise option. A noise seed is going to be 0 for the last one, but for the second one we are going to use our seed. So CFG for the first one is going to be 3.5 or 4. I will use 4. Light, these are, remember, light 2x LoRAs, so they have to be CFG1. Euler simple, Euler simple, Euler simple is fine. Return with leftover noise, very important. Of course, we want to return the leftover noise to this guy, and from this guy to this guy. So this is also going to be enabled. For the self-forcing LoRAs, recommended for SVI is like 3 steps. So what I'm going to do, this is by the way going to be 1 step only. Okay, so I will do start at step 0 and it will end at 1. So we will only create something at 1 step. And then for this one, we will of course start with 1 and then we will end at 4. And for this one, we will start with 4, of course. Okay, we are following it. And we will end at 7. And control after generate for these two, I will make them fixed. And of course, very important steps, I will keep them as 7. Okay, so 0 to 1, 1 to 4, 4 to 7. Return leftover noise, enabled, enabled, disabled on this. We are adding noise in our first pass. In our second pass, we are not adding noise. In our third pass, we are also not adding noise. Okay, I keep like double checking it because a small mistake which I did when I was preparing the video, just like something small, I forgot now what was it. I think it was about my base model. I spent like 2 hours to understand where is the problem. Then I was, okay, then I understood that I was not adding the LoRa. So yeah, so that's why always double check that you are doing the right thing. Now, you are doing something, you are going to say, okay, you created those and you have lots of like get nodes, set nodes we created to define our model, stuff like that. But this is a subgraph. If you try to, I wish they will add this feature in the future, but get node is not going to work in subgraph. Okay, so it's, I don't know, it just doesn't understand the root level, I think. But no problem. The beauty of this subgraph, this is my input. Now what I'm going to do, I am going to go from my model, okay, to this, okay, and I will call this base high. And from this one model, I will go here, I will call light high, and from this one light low. From this one I will keep, okay, let's do capital variation autoencoder. We need clip for these prompts, of course, clip and clip to same. What I was trying to say about order, I wish there was a way of reordering this, but there is no way right now. You can right click, disconnect the link. If you disconnect the link, it will keep the input but disconnect, and you can remove the slot. So it will remove it. Okay, so what else we need? We need, we need length. This is the way the model works. This motion latent count for the initial should be set to 0. Okay, very important. So length. What else I need? For this workflow, I don't want to expose some of these to root level. For example, I can expose step, CFG, start step, end step, and I can do like set and get nodes in the root level and connect to those and change from the root level. But in my opinion, we can keep it as it is, because in the root level, I don't want to connect too much stuff. I want to keep this as much as simple for you guys to understand better. So what else we need? Okay, like I said, most important thing, anchor samples, okay, and previous samples, okay, base high, light low, variation autoencoder, clip, length, anchors sample. Where is my seed? Yeah, noise seed. This is very important. We will connect it to like this. And of course, for the high one, also we need this one. We can do a save. Now what I want from this to this, oops, and I want to call this samples from. So what's happening here? I am getting an output with the latent itself. So it is still encoded. But for the second option, I am getting the decoded option, decoded version of the latent. That's why I will call it decoded images. Okay, one is not decoded, one is decoded, and we are done. So now if I go outside, here it is. You are going to see we have an input for base high, light high, light low, variation autoencoder, clip, anchor samples, preview samples, and it is outputting samples, decoded images, and it has a noise seed in here and a length. So now what is important, I want to be able to write my prompt outside, because I don't want to go inside this to write my positive prompt. Very easy. Right click, go to, where are you? Edit subgraph widgets. Okay, these are the widgets that's available for you to expose outside. If you find clip text prompt, oh, let's make it like this. Clip text encode positive, just to make it more easy for us to understand which widget we are choosing. Now if I go outside, right click, edit subgraph widgets. Where are you, my friend? This one, clip text encode positive. Click on the eye icon, and now this is the section we can put our prompt. Okay, let's go to, these are going to be in this section. Now we want something, we want to create our LoRa section. Let's make some room here. There is a very strange bug. I cannot move this group. I don't know why. Anyway, I will make some room here. How the LoRas are working? Chaining. Okay, we are going to chain SVI. So for example, what I'm going to do, I am going to Alt left click duplicate this, Alt left click duplicate this, and this is going to be my SVI2 Pro high, and this is going to be my SVI2 Pro low. Now we need to change the order. So this will connect to this will connect to this, and now this will connect to the model, and this will connect to the model like this. Okay. By the way, don't forget when you are in our workflow, when you are switching between text to image and image to video, change your LightX LoRa's to image to video or text to video. For this one, I am going to choose SVI Pro image to video high, and for this one, SVI Pro low LoRa rank. Okay, strength 1 is recommended. That's it. Be connected. We need one more thing. Because we are using 3 samplers, we need a base high model without light X2 LoRa's. I just want to use the WAN 2.2 model itself, but of course I still need the SVI for it. So remember, we did something like this. What I'm going to do, I also want my model shift. So what I can do, I can duplicate this guy, which is the image to video high. We want the high one. So I will duplicate this to here like this, connect to this like this, and set node. And I will call this SVI base high and connect to this. Okay, let's double check. Image to video high noise, image to video high noise, image to video low noise, image to video low LoRa. Okay, Control S to save. Let's go to here. Before going that, this is still an image to video LoRa. We don't need to create a separate load LoRa section. We can just use this one because we are setting our image in here, which we already have the set image node. So what I want, we cannot use this sampler, this latent group here, because this latent group is for our multiple samples that we are using with standard latent, triple latent, ClownShark, etc. For this one, I want a different latent. Very easy. I can do get node and image. I will get my image. And what would be nice, actually, we can do like a resize image. Okay, it would be a nice feature if you want to resize the image that you are putting. Maybe you find an image from internet or something like that. You can resize quickly. This is going to be like upscale method of Lancos because it is the best one. So for example, I can do like 832 to 480. This is like 480p. What is it called? Resolution. Keep proportion. I don't want to stretch. I want to crop. Center 2 is fine. And now what we are going to do, we are going to get node, variation autoencoder, variation autoencoder. Remember, this is an image. We need to turn this into a latent form. Set node, and I can call this anchor samples. Control S to save. Let's go here. Now let's plug our stuff. How many get nodes I need? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is going to be my SVI base high. Connect. This is going to be my light high. Connect. This is going to be my light low. Connect. This is going to be my variation autoencoder, my clip encoder, my anchor samples. We are not connecting anything to previous samples because now you are going to understand that previous samples is for the second clip. For the second clip, we want to get previous samples as an input to create our long video. So, oh, actually I need 2 more. This is going to be my seed and this is going to be my length. Collapse. Let's collapse everything. Let's tidy this space. Let's double check we connected everything right. This is our SVI base high. Correct. Light high, correct. Light low, correct. Variation autoencoder, correct. Get clip, connect. Anchor samples is connect. Previous samples is empty. It is going to be used in the second clip. Length is connected to the length and text is empty, and seed is connected to the noise seed. Now, this is it. The setup is already there. Just I want to double check something. Let's go inside. I am just trying to see if I am missing anything. Positive connected, negative anchor. Okay. Previous samples. Okay. So for example, for this for the initial one, I don't need this connected. This can give me a problem because we don't have a initial previous sample for this guy to work. So it needs to be empty. What I can do, but I still want that input because I am going to duplicate this subgraph. So rather than removing it, you can just disconnect link. Now it is empty and this guy is empty, as you can see. Latent image connected, everything is connected, noise seeds, everything is connected, everything is connected. Further samples, decode image, perfect. Now it is very easy. Let's say now you want to create your extension clips. Alt left click, duplicate, and let's call this extension 1. I'll make it like this. I can literally connect it like this, but I prefer not to. I will do like this because like I said, I don't like these noodles going all over. I hate that. Light high, light low, variation autoencoder, clip, anchor samples, length, seed. Oops. Now, most important part, how this works, like how these two getting connected. So it is super easy. This previous samples needs the previous samples. So this needs to this needs to connect it to this like this. Okay, but for the extension, okay, so this is the unique one. For the extensions, they are all going to be same. So for the extension, we need one more thing. So I will go inside extension 1 like this. Now I can connect this previous samples to this so it can work. I will go here. This is the most important part of this workflow. We have a node called image batch extend with overlap. Again, it is from the KJ nodes. So this extended images are the new images that we need to use every time we are adding a clip. So I will connect this to here. It will get the name extended clip. And for the extension, I can still use decoded images. Let's remove this. I don't need this in here. So I need samples and extended images. And latent is connected to the latent. And now this is a new generation, right? So what we need to do, this variational, we are creating something new. And it is of course going to connect it to the new. What is very important, source images. It needs to get the previous images and blend them together with new images. So they recommend this value overlap 5 and everything can be stay exactly like same. What we are going to do, we need to expose these source images like this. And just to make more sense, I can double click and rename this as previous images. Very important. Recommended value for this, for the extension clips, motion latent count is 1. Okay. And everything here is same, of course. Now we will go here. As you can see, now we have previous images, which is going to be connected to decoded images. Okay. Okay. Let's see. Now everything is connected as far as I see. Let's make some room so we see much better. Okay. The only thing that we really need to do in this case is duplicating this. I want to create 5, 10, 15. Okay, 15 seconds of video. Okay, that's great. It is up to you. You can increase that for the sake of tutorial. Let's go with 15. I can do extension 2. Let's connect. Oops, I duplicated extra. Let's remove this. Previous samples to samples. Previous images to extended images. This is done. There is a known issue with some of the generations. This is a very new also LoRa. There is a slow motion problem, especially if you go lower resolution, lower size. Keep that in mind. You can get like some slow motion effect and you need to change your prompt according to that. You can add like 24 FPS to your positive prompt, etc, etc. But now this is going to be my rendered final image. So I will set a node and I will call this SVI video. Okay, what I want to do also, a nice little feature, I can add a preview for my each clip video combine. Let's make this 16 because we are doing the native FPS here. 1 2. Let's say 1.2 and H264 MP4. This guy, this is fine. This is a preview. I don't need higher number for CRF. It is the encode level. I can turn this off, and I don't want to save this. So this can connect it to decoded images. Okay, preview initial, and I can duplicate this, make some room here. I can also preview extension 1. Let's save, group them, SV2 Pro long video gen. Okay, this is it. You need to duplicate the extensions and chain them together like this. Now we can go to our interpolation section. What we can do here, this is the previous generations, image to video, text to video. As you remember, we are getting the final image from them, from this latent section, as you remember. But now we have new images from SVI technique. So I can do get node, SVI, did I call it SVI video? Yes. I am wondering if the switch is going to work between these two images. If I connect this to input 01, to input 02, to image, this is a preview without post-process. The only problem right now that can happen, I can get an error because of a empty latent that we here, empty image that we set here. Okay, because this is now empty. Let's see. Where is it? Why? This is huge. Control S. If I run this, okay, I have a problem here. Where is my image? My image is here. Let's go inside this. Oh, there is no text. Let me open quickly my ChatGPT. First prompt is a woman is sitting by a window in a cafe, holding a cup of coffee and looking down at it quietly. Second prompt, she brings the cup closer and takes a slow sip, her expression calm and thoughtful. Third one, and the last one, she gently places the cup on the table in front of her, blah blah. Let's run this. Okay, something is missing. Let's see what we have in our prompt. Coded images. Oh, you see? Very important. Don't forget and do stuff like this. Let me double check. This one connected. Okay, I think we are fine. Okay, our generation started and let's see what's going to happen. I will see you when this is done. This is a very basic prompt and still it is something, but yeah, I will definitely improve the prompt. Prompt is very important in WAN 2.2 because WAN 2.2 is super prompt sensitive. She brings the cup closer and takes a slow sip, her expression calm and thoughtful. Okay, she gently places the cup on the table in front. Anyway, let's look at the final after interpolation, and here are nice long video, and the blend is super cool. Like I said, this is a very brand new LoRa, and in my opinion, Light 2X LoRas, I said this in the beginning of the video, they are, I am not going to say killing, but they are limiting WAN 2.2's actual raw performance. So you can disable them and try, and you will get so much more better results than this. But of course, if you are on low VRAM, you can continue using Light 2X LoRas. And I am pretty sure there is going to be an update because I was reading on their GitHub about some issues. Yeah, there is like some kind of like slow motion issue with some resolutions, but every LoRa is getting retrained, getting fixes. So this entire workflow is going to be free on my Patreon, which will be always the case for this YouTube channel. And whenever there is an update on SVI or something that I find, like maybe I can add like a LoRa, something called PUSA. It's a different LoRa that is, they are claiming to give like more dynamic motion. I didn't try it. We can introduce it. So anyway, you can join to my Patreon for my free tier, and you can always get my latest updates. When there is an update about this file, I will post all my workflows there. Yeah, so we created an entire WAN 2.2 all-in-one workflow. We created a text to video, image to video. We used standard 2 K samplers. We introduced TripleKsampler. We introduced a ClownShark. What was the name? ClownShark Sampler. And we introduced interpolation. We introduced post-processing effects. We introduced SVI2 Pro. Let's make this capital. Yeah, in my opinion, nice all-in-one workflow that we created. I hope you guys enjoyed it, and I know this is a long video, but my videos are going to be long, and because the workflows are long, so I don't want to skip stuff. Sometimes I may be reintroducing some of the stuff I already introduced because there are so many like things, CFG, C, blah blah, prompt, NAG. So sometimes I forget and think like, well, maybe I didn't talk about this before. So if I am doing something like that, if I am repeating myself, sometimes I'm sorry for that. And but in my future videos, for example, from now on, I'm going to skip like what is a sample, what is like steps, what is like high LoRa, what is low LoRa, stuff like that. I will only introduce something that brand new, like in like a node we never used, for example. So please try to use this workflow by disabling self-hosting LoRa section, at least to see what is WAN 2.2 is capable of. I don't suggest going below Q8 GGUF. In my opinion, going below that, you are limiting and killing too much features of WAN 2.2. The lowest I would go is Q8. And what else I can say? In this workflow, it is not done yet. I am going to add some nice info tables that you can read. What is what kind of length you can use, etc. What is like a nice resolution. So I will put some like information text maybe in here. And let's see. This is using Sage Attention by default. When you installed my ComfyUI installer, remember, we run the ComfyUI with ComfyUI start dash ComfyUI dash Sage. That means Sage Attention is applied overall in ComfyUI. So if you guys are thinking about why he is not using like this node, patch Sage Attention, this is a node. If you run your ComfyUI, if you installed Sage Attention, but if you didn't run the alias to enable ComfyUI. So you can run a native ComfyUI after you install the Sage Attention as a Python library. Then you can use this for workflow specific. So if you want to improve this and do it, for example, like that, it is very easy. This is going to be connected to your models, and that model is going to be connected to these inputs. Okay, so after every model, text to video low high, image to video low high, patch Sage Attention you need to enable and set this to Sage Attention auto. What else? Oh, we are using UNet models. If you want to, I was just talking about GGUF. It is very easy. Rather than using this, I didn't want to create extra steps like switches, stuff like that. I don't want to make it like more complicated. In my opinion, you should be already knowing it before my clips. It is super easy. I will show again. You can just load GGUF, this guy. You can use this, or model loader. Oh, I think I don't have that node. If you have the KJ node, nodes, which we need for this workflow, so you can just use loader KJ for this one. You don't even, for example, need to define Sage Attention if you are using native ComfyUI. This also has Sage Attention. Was it? No, sorry. Yeah, it has. You can use Sage Attention like this if you are not running the alias when starting. So yeah, you can. I don't have any GGUF models. You will select your GGUF and that's it. Then you will plug it to like this. So one for text to video high, text to video low, image to video high, and image to video low, and just bypass this. So these models are going to be connected to wherever I connected these. That's it. And if you are using GGUF, also don't forget your clip loader GGUF. Then you need to use this guy, and this guy will be connected to this. Okay, you will select your GGUF version of the clip, and don't forget, very important, select one and connect it to clip this, and you have a GGUF enabled workflow. My personal recommendation for creating videos for WAN 2.2 is image to video. In my opinion, text to video is like a big lottery and you don't know you are waiting for something that you don't know. But in image to video, at least you can go to, for example, my workflow, Flux workflow. You can create like a very nice image in a so much more short time. And you can say, oh, this is my starting image. In my opinion, go to an image generation tool like Flux, for example, and create your start frame as much as you want it to be, then use image to video. And image to video, in my opinion, also giving much more nice videos, because you are starting with a much more like detailed, high resolution image to start with. Text to image, in my opinion, fun to play with, but it is like too much unknowns for my taste. But yeah, this workflow has all of it. Okay, let's go to the end of our video. Thank you so much for watching and for spending your time with me today. If you have any questions or if something wasn't clear, feel free to leave a comment below. I read them all and I'm happy to help. In the next video, I will be diving into 3D model generation inside ComfyUI. This one is especially exciting for me since I am coming from a VFX background as a 3D modeling and texturing artist. We will take a look at what the current options actually look like right now and what is realistically usable. If you enjoyed the video, don't forget to like and subscribe. It really helps the channel grow. You can also join my free Patreon tier to grab the workflows I share there. And if you'd like to support future videos and more advanced workflows, I also have a supporter tier available. Thanks again for watching, and I will see you in the next one.